All right, everyone. Thanks for coming. I will start this off myself. Lots of familiar faces here. My name is Martin Kjellin. I'm a tech lead inside NSO Engineering. And today I'm going to give an update about the state of NSO high availability solution. So I've updated my title a bit from the agenda. So it's now called What's New and What's Next, HA Raft versus Rule-based HA. So I will not go into detailed configurations and detailed deployment model. I will look at it from a higher perspective. So I will also touch upon the promised things at the end. What to use when you should choose rule-based HA and when you should choose HA Raft. But in order to get there, we need to orient us a bit around what is what within the world of NSO HA. So when we talk about this, and when we do that quite often in these settings and others, we talk about NSO HA, high availability, as kind of a one thing. It's actually made up of various features, various parts of the system, various packages, but you can look at it as three major areas that we cover. One is replication and catch-up, which is how we transfer data from one primary node to a secondary, and what happens when they are not connected on a catch-up. That's like one functional area of the NSO HA solution. The other one is the logic of defining which one should be the current active or the current leader. So you can call that leader election. You can call it failover logic, depending on where you are. But functionally, that sort of solves the same problem, right? And then we have the third, which is kind of orthogonal to the other, is announcing the primary node or advertising how to route traffic to the current leader, because regardless of using HA Raft or using rule-based HA, we always have exactly one. We only have one active node that should take writes in theory. So where we are right now, the HA Raft as a feature covers kind of both replication and catch-up, as well as primary node election. And same for rule-based HA. This means that replication has a different transport mechanism depending on which solution you choose. And also the behavior for after a net split or when you add a new node differs. When it comes to the primary announcement or how to route traffic to the current leader node, that is handled either in DLF HCC or with a feature called HA primary listen. You might also want to add the notion that we have notifications in our notification API, which is not that widely announced, but it's possible to get notifications when a node becomes primary. So you can get that, be notified for that, which is useful. I have seen people using other methods to determine that. So HA Raft, what is it? We released it as part of NSO 6.1, I'm quite sure. And it's based on the Raft consensus algorithm. The main, if you want to summarize this with a few points, it eliminates the risk for split brain. It also has solid guarantees with regards to a write being replicated over more than one node. It also offers an optimized sync behavior if there's a difference between nodes in what commits they have taken. You don't have to do a full sync all the time. And not strictly related to the Raft algorithm. This features also comes with application level encryption of the HA traffic. It also has a very simplified operation and maintenance. It's designed to be hands-off. You should trust the system to do its thing. And so once you have it set up, you're not expected to need to do so much more with it, which is one of the selling points. rule-based HA. For a while, we called this NSO built-in HA. Before that, we had a similar solution. It's the traditional one that we've been running for a while. It has some other characteristics. For example, it allows writes in a single node. If you go back to HA Raft on the second point, that means that you need to have at least 2 nodes up to accept any writes. And here, it's not autonomous, it's semi-autonomous, but we do allow operators or other systems to set the state of NSO's HA. You can instruct it to be primary or be secondary to a primary node, or disable and enable and be second and failover. There is quite a lot of options on how to configure your failover logic, what should happen at the net split, which nodes are eligible to become primary. Also, we have a system for nominal roles and what should happen at startup. At the moment, the rule-based HA does not offer application level encryption. We delegate that to the transport layer or to the operator to solve. So this means you can run a 2-node system, a traditional system. It means that 1 node can die of those and you can still take traffic. It also means that there is a risk of split brain unless you configure everything or managing everything perfectly. So there is, it's flexible and you're allowed to do lots of things. And I would like to underline that this fits different needs, these 2 solutions. So we are honestly not planning on deprecating any one of them. We keep them going as they are sort of tailored to different scenarios. I touched a bit upon primary announcement and routing. So for those of you who are new to this is in an external package, but delivered and supported by us, called TAILF HCC. It provides a layer 2 virtual IP address or a layer 3 virtual IP address through BGP Anycast. And this is optional to use. You can use NSO HA without it. The other solution that we offer for this is a feature called HA Primary Listen. It opens a set of traffical port only on the current primary node, so that you can use something like a load balancer and TCP liveness probe to find the current primary node. And this is controlled through the ncs.conf configuration file, so no external packages or other dependencies are needed here. Okay, before I get to the part what to use when, we might want to take into account what has happened recently feature-wise on these 2 solutions and a bit what's planned. So what we have done lately, on the HA Raft side, we have introduced support for IPv6. We have improved logging and observability, so it's easier to set up and it's easier to follow what happens when you set it up than it was in the first release. We have added an action to basically remove all HA Raft configuration, which in some scenarios, such as upgrades, can be very useful. These are the latest things released around HA Raft. When it comes to rule-based HA, the big news there is that we removed the CDB compactions after a sync, which means that the service unavailability is lower. We were quicker back to taking traffic after net split. We have also simplified it a bit when setting this up. There was a common thing that happened the first time you set it up, that we accepted different database encryption keys between the nodes and transferred encrypted data, which led to unexpected behavior, but that security measure is now in phase. On the TAILF HCC side, we have a couple of new features updated lately. One is called site location support. This requires some explanation. In general, in NSO, the database is mirrored exactly as it is. Everything is transferred completely. So if you read a path on your primary, it will be exactly the same if you read it on your secondary. So if you want to store some data that is specific for a particular node, it can be tricky. There are tricks to it, such as in a list having a key, which is the IP address of the current node, and store the data under it. It will be replicated, but you can find node-specific things. This, however, is a bit tricky to use. It can be many round trips, or you have to know the IP address of the node you're talking to, or query it. So it's not always perfect. But Tail-F HSE now has a support where you can support that. You can provision site node-specific data, and you can retrieve it via an action. So it's a one-trip call to get that. The main use of that is if you're hidden behind a load balancer or one of the other virtual solutions, you can easily query which node is currently active there, and that helps sometimes. It's now also possible to update DNS on failover, or when a new primary is elected, we can call DNS update straight from Tail-F HSE, so you can use DNS for the traffic routing. I don't remember the exact Tail-F HSE version that has this, but if you use the newest one that we provide, you have this. So what do we have planned for these two? That this is more or less in the 6.4 time frame, which comes end of this year, so what we're doing right now. Biggest thing on HA Raft is that we are introducing a passive follower role, which means that it's a node that will be part of the leader election. It will replicate the data, but it's not eligible to become the new primary. And this has actually been requested from several users. One of the reasons is that you want to deploy your 3-node HA Raft cluster with one node in a separate data center which does not have device access. You don't really want to run things there. And it gives you a bit more flexibility in how you provision your nodes. We will also introduce an observability status page in like a dashboard in the web UI, which supports HA Raft, so you can see the status of where you are. As for rule-based HA, we have two major items in the work. One is to improve the sync time when you connect the secondary to a primary, and they have differed CDBs. This is currently looking very, very promising. I was hoping to show you some figures, but the figures I have are too good, so I need to verify them, which is a good problem to have, but I don't dare to advertise them just yet. We are also introducing application-level encryption on rule-based HA by using the same transport mechanism as we do in HA Raft. So we're simplifying that part. It will be the same way of handling this and the same way of transferring data between. Okay, so now everyone knows enough about our HA solution to kind of make a decision on what to use, when. And our normal question in this kind of areas is it depends. And I would like to be a little bit more opinionated on that. I don't think it's super hard choice depending on if you know what you want. So I would try to reason about it like this. If split brain automatic avoidance of it is a top priority for you, but you see that this is something that you never want to happen and you don't want to deal with it, HA Raft is your go-to thing. There is a greater risk of split brain with the rule-based HA. And if you want and are okay with an autonomous operation on the NSO HA, then definitely go with HA Raft. For rule-based HA, I would say use it if you are looking into something more traditional, an active standby situation, and that's the kind of solution you're used to or what you want. And you want to be able to take writes on a single node. You don't strictly feel that you need to have a 3-node setup and replication all the time. The other reason to choose it is that you want to integrate this in a greater solution where you control the state of NSO HA externally. You might have this as part of a bigger thing and you want to fail over everything at the same time. You might want to delegate the decision to which site or which node should be the current active to something external that you already have in place. And then we have the methods to do that. That being said, if you start from a blank page and you push me to the wall and say, what should you, none of this really, I don't know. I don't have any external requirements, I'm starting from scratch, I can design this as I want. I would choose the left column. I would start with something new now, and I don't have any of the requirements on the right side. I'd go with Raft. It has, if you can avoid messing with your HA state, if you can avoid having a split brain and everything, and if you can let the system run its course and do its things, I think you will have an easier life as an operator while maintaining it. That being said, majority of our deployments are definitely on rule-based HA still, and it's no major issues there. It's trustworthy, it's tried, it does what we say it does, and we are continuing to improve it and optimize it. So adding features and performance improvements. So that's it from me. Do you agree with me on my statement on what to choose when and the characteristics of the HA? Because I know at least a few of you in here have toyed with this. Or any other questions? Sure.
I actually have 3 questions, if possible. The first one, regarding passive follower, I just haven't noticed if it is already implemented or it's in plan. Passive follower, right?
Yeah,
What's
no,
next?
it's coming in 6.4.
Okay.
Next long-term release, yes.
6.4, okay, thank you. The next question is, how often have you seen customers implementing their own HA solution? Or and how successful it was? What the experience, if you know about it?
I can say that some of our major Cisco solutions are using the framework, so they're using this, but they are not using the logic, our failover logic. They have no roles defined, and they don't have any failover logic. So they use it externally in say if you run CNC with the Euro redundant setup, then they use it externally. So it happens. In the field of direct NSO users, on the top of my mind, I don't think anyone really has implemented their own, but Cisco Solutions has.
Okay, and the last question is, if there is any thinking around having active cluster?
Yes, but we are not close enough to put it on a roadmap, so that's more of a question if you're in the research session.
Yes, exactly.
Yeah, it's in that area. Yeah, it's.
You have it in mind.
It's a long-term goal. Yes.
Thank you.
We want to get there. Thank you.
So if a customer won't have a HA Raft, is that possible that we use only 2 NSO nodes? I mean, in your picture, you show the second case there. We lost one node there, and we do have 2 nodes connected, in the middle there. So if a customer asks if we can just have 2 nodes use a Raft?
Theoretically, yes, but you don't get any availability, right? If you lose one node.
Yeah, probably in the beginning step, they have 2, then they probably expand 1 more in the future.
I guess you can.
Okay, but that means doable. I
mean, you might have problems setting up at first, but you might need to set up 3 and then remove 1, practically. But it's also the things that any failure there, and you don't have any availability of the system, right? Since it requires 2 to be up, and then that's split and a node goes down, your service is gone. So it's not something I would recommend. I would stick to the 3 or 5 recommendations.
So the only downside, so far as I understanding, compared with the other option, is that they for customer side, they need to invest more to get 3 there, right?
You need more nodes, and you lose the ability to control it. That's and the second one is both a plus and a minus.
Yeah.
It's what you don't want. Okay, if you're going to go into that a bit more deeper as well, in general, I would say for like a GeoHA setup with a call standby, that you probably don't want Raft, because you probably want your secondary entire site to be a manual procedure to switch over. You don't want an autonomous system saying, hey, I should use the site in the other system.
Yeah.
Probably not, but that's...
okay. Yeah, thanks.
Maybe I share my idea related to that passive follower that I came up with, is that maybe may think of a use case when I want a passive follower that will have a role of arbiter, not thinking database, but just checking the availability that, I can reach those and those guys, but I may not want to have a database actually. So that's an idea that maybe, and put it as close to my customers, let's say, to my consumers of my API, and not having the actual data, actual packages, and so on, but only to check from their point of view if they can reach one NSO or another, but not having it in my cluster, not only having it in my cluster.
Yes, that's doable, and it's not a bad idea. I would probably want to have like a 5-node setup then, so you have 2 + 2 and an arbiter node somewhere. For a 3-node, then you lose the replication part, but maybe you're fine with that.
Yeah, if it would be lightweight, then I can deploy them in all data centers I have, for example, and have a quorum on that. Yeah,
I think it's Adam, what do you say? You're not.
Without data, it's hard, because when the quorum means all the nodes. The quorum means all the nodes got the data. So if something needs to be recovered later on, you can go to any nodes and give me your data, and I'll recover from that. And if one of the nodes is saying like okay to quorum voting, but not keeping the data, then that's false information. But if you want to monitor the topology, I think external tools can be developed for that.
I'd say if you go with the witness node, I think that's what you were describing, right? Yeah. So that's when you lose. It's more like the rule-based HA, but without the split brain thing, in the way that you lose durability. Like with Raft, once a write goes through, you know it's on at least 2 nodes. And even if one node goes down, you'll keep your data, at least on one other node. But in the witness case, if the node with the write goes down, then it's gone, right? You lose your rights.
Yeah, so replication is important. The passive nodes will join elections, will vote, will join quorum voting also, but not become, if you know HRF, it won't become candidate. Candidate means it becomes a candidate to be a leader. So that's the idea there.
And if the leader is not available, then you need to have manual actions.
If the leader is not available, say in the first is the healthy one there, the orange one goes down. The other 2 nodes, after timeout, one of them will become a candidate. And say one is passive, that won't become a candidate, the other will become a candidate. And the one not passive one will vote okay for the other one, because it knows that it's not going to be a candidate. And then the non-passive one will become the leader. It will continue with 2-node system.
What's the use case for active-active? I hope it's not performance, right?
Yeah, it's generally looked at for performance.
Performance.
Yeah.
Okay.
Yeah. Performance, horizontal scaling. If you're able to use compute resources on a wider scale, you can not run everything on one.
And you can manage consistency by slightly having a little bit worse consistency then, I guess.
I mean, I'm not saying this is a solid thing. That's the reason for it. But yeah, no, it's tricky.
I was just asking what you're using. So obviously it was performance, right? So.
Yeah, right. No, I was thinking about the active scenario. I mean, sometimes it could be just a simplification of the deployment, right? I mean, you don't need to manage the high availability setup, and that depends really about the use cases that you are implementing. Not.
All right. Thank you all for coming.